Okay students, let us try to solve this question. It says, which of the following are isoelectronic species, that is those having the same number of electrons. Okay, we are aware that isoelectronic species means the one which are having the same number of electrons. Okay, so let us try to solve this. Isoelectronic species means those having same number of electrons. Same number of electrons. It is no doubt given to you in the question, but then still you are supposed to understand the meaning. Maybe this particular part, that those having the same number of electron, is not given in the question. Hence, you should know the meaning of isoelectronic species. So here those species having same number of electrons are referred to as isoelectronic species. They can be an atom or can be an ion of it. Let us take the examples which are given here. It is sodium. So sodium, you know, has an atomic number of 11, but they have given you here Na plus. Now in sodium the number of electrons you will have is 11, but what is the number of electron in sodium ion and how do you find out? So this would be 11 minus 1 is because you are having 1 plus sign. It loses 1 electron out of it, so finally it has got 10 electrons. Sodium ion has got 10 electrons. Now similarly, if we talk about potassium, its atomic number is 19. So potassium ion K plus is given to you here. So as atomic number for potassium is 19, then number of electrons in it would be 19, but then K plus is there, so we will have to remove one electron. Only then it forms K plus, so it is left over with 18 electrons. Now next what you have is magnesium 2 plus. So magnesium atomic number is 12. Now you are given Mg 2 plus, which means originally magnesium was having 12 electrons. Now when it forms 2 plus, you need to subtract 2 from it because it is forming plus. So then you are left over with 10 electrons here. Then next example you are having of calcium. Calcium's atomic number is 20. Now it forms Ca2 plus. So how many number of electrons it has? Calcium was having 20 in it, and plus 2 means it is removing 2 electrons. So it is having now left over with it as 18 electrons. Now after calcium you have sulfide ion. So sulfur is having atomic number 16. Now when it is forming S2 minus, here the thing which you need to understand is sulfur will have 16 electrons. So 16 electrons are there, but then 2 minus is there. 2 minus means it takes 2 electrons. When it is charge is in plus, that many electrons it loses, but now here in sulfur you are having minus 2, so it gains 2 electrons, and so the total number of electrons which sulfide ion will be having is 18 electrons. Now you are having last is argon. Now argon is neutral atom given to you over here, as its atomic number is 18. Here argon will have 18 electrons. So now here if you will see all the species final number of electrons we have seen, you have got, but then let us try to make the set out of it. You can see that this Na plus has 10 electrons and Mg2 plus has 10 electrons. So first set of the isoelectronic species includes Na plus and Mg2 plus. Then all rest you will see will be forming second set of isoelectronic species having 18 electrons, and you can see that they are nothing but your K plus has 18 electrons, then calcium 2 plus has 18 electrons, then S2 minus has and lastly argon has 18 electrons. So these all are having 18 electrons in them, but all these are having 10 electrons in them. So there are two sets of isoelectronic species bearing 10 electrons and 18 electrons in them. I hope you have understood how you need to classify the sets of isoelectronic species and also the meaning of isoelectronic species. Thank you all.